Explain the principle of operation of a DC generator. We know that an electrical generator is a device which converts mechanical energy into electrical energy. This energy conversion is based on the principle of electromagnetic induction. Which states that whenever there is a change in the magnetic flux associated with the conductor, an EMF is induced in it. This induced EMF causes a current to flow if the conductor circuit is closed. Therefore, the two basic essential requirements of an electrical generator are the magnetic field and the conductor which can move so as to cut the magnetic flux. Thus, we can say that a DC generator operates on the principle of dynamically induced EMF. Now let's discuss how a DC generator operates. Consider a simple loop generator. Let's rotate its single-turn rectangular coil, say ABCD, about its axis in the magnetic field. Note that both the permanent magnet and electromagnet can be used to produce the required magnetic field. We see that as the position of the rotating coil changes in the magnetic field, flux linked with it also changes. Thus, an EMF is induced in the coil in accordance with the Faraday's laws of electromagnetic induction. This induced EMF is proportional to the rate of change of the linked magnetic flux. We also see that after every half rotation, the sides AB and CD of the loop swap their positions. Thus, the direction of current flowing through them gets reversed. Such a current undergoing periodic directional reversal is known as alternating current. To change this bidirectional alternating current into unidirectional DC current, split rings are used. These split rings are made of a conducting cylinder which is cut into two halves or segments insulated from each other by a thin sheet of some insulating material like mica. The ring segments are also kept insulated from the central shaft and are connected to the ends of the coil and the carbon brushes. Now let's discuss how these split rings change the bidirectional alternating current into unidirectional DC current. Let's assume that current is flowing along ABCD. We see that brush 1 is in contact with segment A. Which acts as the positive end of supply. And brush 2 is in contact with segment B, which acts as the negative end of supply. Therefore, the direction of current in the load resistance is from M to L. Now, after half revolution, direction of the induced current in the coil reverses and it begins to flow along DCBA. Also, position of the segments A and B gets reversed and brush 1 comes in contact with segment B. Which now acts as the positive supply. And brush 2 comes in contact with segment A. Which now acts as the negative supply. Thus, we see that the direction of current in the load resistance still remains to be from M to L. We also see that the position of the brushes is so arranged that the changeover of segments A and B from one brush to the other takes place when the plane of rotating coil is perpendicular to the plane of magnetic flux. When EMF induced in the coil is 0. Thus, we see that similar to an AC generator, current induced in the coils of a DC generator is also alternating. But due to the rectifying action of the split rings, current across the external load becomes unidirectional. This action of split rings is known as commutation. Related terms are